Without a doubt, technology is the beating heart of modern life. In this program, we will introduce you to one of the most important needs in technology, the microchip or integrated circuit, which is the beating heart of all electronic and technological devices that we all use today, such as mobile phones, computers, cars, and all electronic devices and artificial intelligence. The beating heart of life is the microchip. The largest manufacturers of microchips are companies like Nvidia, AMD, Qualcomm, and several other well-known companies. These companies produce billions of chips every year and are in fierce competition to make smaller and smarter chips. Stay with us until the end of the program. Also, to support us, do not forget to like the video and subscribe to the channel. For the first time in 1958, Jack Kilby, an engineer at Texas Instruments, made the first integrated circuit or microchip using germanium. Germanium is a material similar to silicon, which functions as a conductor and switch for electronic currents. A year later, Robert Noyce from Intel improved the chip by using silicon, a more efficient and abundant material. This was the real beginning of the microchip revolution. Since then, progress has been very rapid, to the point that in a modern factory, billions of microchips are produced every year, and each one is the result of highly advanced and precise engineering, almost like something out of science fiction movies. You might be wondering how microchips are made inside a factory. Everything starts with a material that may seem useless to you, sand. But not just any sand, specifically sand that is rich in silicon. To turn sand into something useful, it first needs to be purified to a very high degree, almost to 99.9999% purity. This is done by heating it in a special furnace to temperatures above 1400 degrees Celsius in a sealed environment filled with a special gas called argon, so that no impurities can enter. The process begins when highly purified silicon is melted. Using a technique known as the Czochralski method, special machines slowly pull and rotate the molten silicon, forming a large single crystal cylindrical rod of pure silicon called an ingot. This ingot typically weighs about 200 kilograms. Although it is about 20 centimeters in diameter, its flawless monocrystalline structure gives it incredible strength, so much so that a very thin thread, just a few millimeters thick, can support its entire weight. However, the ingot is not used in this raw form. It is precisely sliced into extremely thin wafers, each less than a millimeter thick, using high-precision methods like a diamond-tipped wire saw. These slices, now called wafers, serve as the fundamental substrate for building microchips. But before fabrication can begin, the wafers must undergo a critical polishing process, often called chemical-mechanical planarization, to become flawlessly smooth, even smoother than glass. This is done with special machines and expensive materials, because even a microscopic scratch or a tiny speck of dust can be a catastrophic defect, ruining the entire wafer. It's worth mentioning that silicon is the hero of this story because it is a semiconductor. This means it can be controlled to either allow electricity to pass through or to block it. This unique property of controllable conductivity is essential for microchips, which contain millions or even billions of microscopic switches called transistors. Without silicon's semiconducting nature, there would be no way to precisely control electrical signals or perform such complex calculations in such a tiny space. With the polished wafer ready, the next step is to design the microchip's function. This is like creating a detailed blueprint for an entire city, but in a space smaller than a fingernail. Engineers use sophisticated computer programs, known as electronic design automation or EDA tools, to create a precise design. This design dictates where every transistor will be placed and how they will connect to each other so the chip can perform its job. These designs go through rigorous stages of verification and simulation to ensure there are no mistakes, because even a single error could cause the whole chip to fail. Once the design is finalized, it is turned into a physical template called a photomask, which will be used to print the intricate circuit patterns onto the silicon wafer. One of the most interesting and critical parts of the process for making microchips is transferring the intricate design onto the silicon wafer. How? This is accomplished using a highly specialized piece of equipment known as a photolithography machine. These machines are often compared to printers, but instead of using ink, they use focused light to draw incredibly detailed patterns. To give you a sense of scale, the features they create are so minuscule, they are actually smaller than a single red blood cell in the human body. This entire delicate process takes place in a special room illuminated only with yellow light. Because ordinary white light contains wavelengths that can damage the sensitive manufacturing process. It's important to understand that a microchip is not just a single layer. It's much more like a complex multi-story building, where each individual floor has its own unique and separate design. Consequently, this light-based patterning process is repeated over and over, sometimes up to 40 times, and with each repetition, a completely new layer is meticulously added. Crucially, every single new layer must be aligned with the one directly beneath it with an almost unbelievable degree of precision. This demand for perfection is precisely why microchips are manufactured in environments called clean rooms, which are kept to an extraordinary standard of cleanliness, a standard that is, in fact, even cleaner than a hospital's operating room. These massive clean rooms can be as large as a sports stadium, and the air inside is constantly being purified by advanced filtration systems, with the entire volume of air being replaced every few minutes. Ultimately, what makes microchips so special is not just the complex way they are made, but also the amazing capabilities they enable in our modern world. The world of microchip development is a field that truly never stops innovating. Every single year, engineers and scientists discover new breakthrough techniques to make these chips even smaller, significantly faster, and much more energy efficient. This continuous progress means that future devices will be substantially smarter and more capable than those we have today, from fully autonomous self-driving cars to revolutionary technologies that we currently can't even begin to imagine. If you have stayed with us this far and found this journey into the world of microchips interesting, we would greatly appreciate it if you would please like the video and subscribe to our channel. Your support is what helps us continue to create content just like this.